All right, welcome back, ladies and gentlemen. We're going to switch gears and talk about something that's probably interesting to anyone who's been watching or owns cryptocurrency. It's my pleasure to introduce Major Ryan Hamilton, who'll be talking to us about blockchain technology. So, Ryan.
Sir, thank you very much for having me. My name is Major Ryan Hamilton. I'm a student at the School of Advanced Warfighting, and this topic was something I've been researching since checking into the school. There has been an enormous amount of hype surrounding all things blockchain, surrounding cryptocurrencies and non-fungible tokens. Non-fungible tokens are a mechanism by which someone could claim ownership of a piece of art that's stored on a blockchain. Many millionaires and sometimes even billionaires have been made by trading in highly volatile cryptocurrencies. I think a good example of this on the slide, you could see CryptoPunk number 5822. It's one of a series of 8,192 pieces of art generated by artificial intelligence that have been sold at auction. This is now considered high art. When I did this presentation in front of the class, I gave them all an opportunity to guess how much they thought CryptoPunk number 5822 sold for at auction. It's $23.7 million was the price tag associated with this. So that's NFTs, and all the money associated with NFTs is unbelievable. Cryptocurrencies now are a multi-trillion-dollar asset. And so this generates an enormous amount of hype. But what if we took NFTs and cryptocurrencies and stripped it away from the underlying technology so that you're only left with the blockchain technology upon which these things are based? What if you take away the hype? What are you left over with? And does that provide any opportunities to the Marine Corps? And that's what I was trying to do with this paper and with this project. So first, the requirement is, well, we got to figure out what is a blockchain. The most useful way to do that is to compare it to a traditional IT system. A traditional IT system is centrally managed. It usually serves the purposes of an individual, an institution, or a government. It has a team of systems administrators that are responsible for operating it. Sometimes it's stored centrally in one location. Sometimes it's distributed on the cloud, which usually just means you pay Amazon to do it for you. Whereas a blockchain is not beholden to any institution or any individual or any government. It's distributed by definition. And it could be theoretically an unlimited number of physical locations in its entirety. So it's a type of software that's just unique from a traditional IT system. You still have a team of developers, but that team of developers doesn't have any more power over the blockchain than I do, despite not being a developer. So that's a quick down and dirty of what a blockchain is. Most of the research that I've seen for the military into potential military applications for blockchain technology have to do with supply systems or logistics systems and things like that. I don't think this is the best application for a blockchain, and the reason is I don't think it properly leverages the inherent strengths of blockchain technology. So in my paper, I make an argument for, well, what are the strengths of blockchain technology and how can we leverage those? And I boiled it down to three things. It's decentralization, immutability, and trustlessness. All right, so let's do a quick definition on what those things mean, and then we'll talk about the two potential applications. The first one is decentralization. That's pretty straightforward. And there's no one physical location, there's no one physical person that can be killed, captured, or in other words, or incapacitated that will render your system unusable or cause it to slowly degrade over time. It's immutable, and that information committed to a blockchain cannot be changed, altered, or even deleted in most cases. And then it's trustless. It doesn't require me to place trust in an institution or an individual. I only have to trust the software. If I want to go to Starbucks and buy a cup of coffee, I have to trust my bank. I have to trust whatever bank software uses, and I have to trust Visa or MasterCard to properly handle that transaction. So there's all kinds of trust relationships baked into that. Well, if you don't have those trust relationships in place, how can you execute a transaction? Well, you have to do it with third-party software to where you just in this case, a blockchain, which you would not require placing trust in an institution. So I know that's very quick, but I'm trying to paint for the audience a picture of software acting autonomously, programmed to act autonomously, that is separate from the individual. And so the question often comes up, well, how is a blockchain immutable? So I quickly want to discuss this idea of immutability, and that immutable means once information is committed to the blockchain, you can't remove it, you can't alter it. And it's pretty simple. Once a certain amount of data or a certain number of, say, transactions are recorded, that's put into a block. That block goes through a one-way hash algorithm. That hash that's generated then becomes the header of the next block. So if I have block 3, that block is complete. That runs through a hash algorithm. It creates a hash, and that becomes the header of the next block. If any change is made to block 3, then the hash of block 3 will no longer match the hash that is the header of block 4. So that breaks the chain of blocks. And this is validated through computational power. It's a blockchain is just as simple a descriptor as you can come up with for describing how information is committed to a blockchain, and when you run the software, how that information is stored. So, quick down and dirty on blockchain technology. Okay, so the first of 2 potential applications for blockchain technology, apart from not talking about cryptocurrencies here, we're not talking about NFTs, we're talking about how could we use a blockchain. I'm a communications officer initially by trade, and one of the issues that we ran into a lot was coalition interoperability. And the best example of this was Talisman Sabre when I was in 2019, where the USS Wasp became something of like an orders hub. We had a small team, a gaggle of officers from every country imaginable, Australians, Americans, Japanese, and they were all located on the Wasp, and it became like an orders clearinghouse. But all of the different components of the CWC construct were assigned to different ships and different commanders from different countries. So if you're worried about submarines, your anti-subsurface warfare commander was Japanese. If you're worried about the air threat, your anti-air component commander was an Australian ship. But in order for the Australians to relay, say, a threat via air to the Japanese, that had to be relayed through the USS Wasp to the other ship. This meant that you had one centralized location, which was the USS Wasp, upon which the entire coalition was dependent. If the Wasp was lost, most of the interoperability capabilities that existed were then lost. And you take away the capability of the Japanese have a very, very good Navy with some very strong capabilities that in many cases exceed our own capabilities. And the Australians also have a very robust amphibious capability, and their Navy is also quite strong. And so we can't operate in the area without our coalition partners. So one potential idea I thought of was, well, if you use the blockchain for, say, targeting, and on the slide you could see a process for how a transaction on a blockchain would be executed. But instead of transaction, replace that with target. So a target is initiated. So a target is acquired. The target is packaged into a block. That block is then sent to all of the members to include the targeting data. The consensus and approval is conducted by the blockchain network, and then that block is added to the chain, and then the update is distributed to all of the members of the coalition, and everyone would maintain a complete list of all of these of the entire blockchain. And copies could be maintained ashore and also in unlimited number of locations. And then you repeat the same process, say, for battle damage assessment. After the target is prosecuted, you do the same thing with BDA and go through the entire blockchain process. This would remove, say, a USS Wasp from being that orders clearinghouse upon which the entire coalition command and control system is based. So the idea is, well, what if we take something like the enormous amount of money that's getting dumped into JADC2 and do research and development for could blockchain technology be a way to potentially address some of these problems? And that's the kind of the central thing of what I'm getting at in this portion of the paper for my recommendation. So in the interest of time, I'll keep going, sir, unless there's any questions there. All right, so the second potential application for this is special access programs. Special access programs are always tricky, and they're not always well managed. The intelligence community budget is something like $80 billion a year, and a lot of that is tied up in very deep, dark corners of the government in special access programs that are very difficult to audit. They're very difficult for leaders to maintain accountability, for leaders to track. And I think a really good example of this is the Autonomic Logistics Information System associated with the F-35. The ALICE is used for maintenance and logistics and mission planning for the F-35, but the ALICE system, if the jet cannot connect to the ALICE system over time, relatively short period of time, the capabilities of the jet will be degraded. So I experienced quite a bit when I was a Commandant 31st MEU, and had to make sure that the ALICE system could connect to a central IT center that was at Eglin Air Force Base in Florida for all of these jets. And if they lost the connection for too long a period of time, then the capabilities of the jet were degraded. The Israelis, when they bought the F-35, famously rejected the ALICE system because it meant that they were relying upon Lockheed Martin. Because this IT center that is at Eglin is operated by Lockheed Martin. It's at a U.S. base. They wouldn't have to use the one at Eglin, but they would have to be able to reach back to another IT center operated by Lockheed Martin that's in Fort Worth, Texas, I think. So there's something like 16 or 17 countries, and Israel said, we don't want your ALICE system. We don't trust you. It's too centralized, and all of the information we don't trust. So they separated themselves from it. Well, that immediately in my mind sparked the idea, well, then what if you use a blockchain to solve that problem? Because then it would be distributed. There wouldn't be one location upon which an enemy could launch a cyber attack to degrade the ability of your entire F-35 fleet. There isn't one location that could be struck that would degrade the capabilities of your F-35, but it was distributed at an unlimited number of locations. It'd also take away the requirement of, say, the Israeli government to place trust in not just the United States, but also the Lockheed Martin Corporation, which I understand why they'd be reticent to do that. So you're trusting the software, you're not trusting the institution, you're not trusting the government. And then for the intelligence community, if a program was made to use a blockchain and access could be controlled, like a blockchain could be customized for whatever the purposes are required, so that if you were going to conduct an audit, sir, on a special access program, you could be given access to certain blocks at a certain amount of time, and any information you access that could all be reported and maintained, so that you could, say, conduct an audit, but you would know that the information committed to that blockchain is not manipulated and it can't be deleted. So no one could go back and cover their tracks, and no one could go back and manipulate existing records because the information committed is immutable. The most famous example of this is a common example is called Filecoin. It's a blockchain where a user can commit information to a blockchain, and a miner. Think of a miner as someone who just operates a computer that is responsible for running the software that operates the blockchain. Okay. He pays him. So if I want to store information on your blockchain, I could pay you in, say, Filecoin, and I could go onto a market, buy Filecoin, and use it to pay you and to store information on my behalf. And then the network of miners makes sure that you are storing that information properly, or that information can be is stored. Or I could commit my own processing power at my own hard drive space to collect my own Filecoin as a reward, and then use that Filecoin to pay you to also store my information. And so it makes your networks far more resilient, but not centralized. And systems like that can be useful for the kind of the mess of SAP programs that we currently have throughout the Department of Defense and the Marine Corps to provide some accountability and clarity on those systems. So this is the idea in a nutshell. This isn't all gravy, and it's not all easy. So I want to talk about some of the limitations and risks associated with blockchain before we wrap up, sir. The first one is I want to talk about confidentiality and censorship. A blockchain is inherently decentralized, not ideologically decentralized. There's no authority that anyone can call to deal with any sort of problems. If someone dumps something that's the wrong classification onto a blockchain for which it does not meet those classification requirements, sorry, there's nothing you can do about it, unless the government decides to launch its own large cyber attack or shut down its own blockchain. Depending on how the government decides to set up the blockchain. So I think the most famous example of this is, do you remember the Marines United event? Mm-hmm. The commandant got on the phone and called, at the time, Facebook, now Meta. And like 24, 48 hours, that was all those pages were deleted, all those accounts were suspended, and the problem certainly was not solved, but the initial issue of information that should not be on the internet was removed from the internet quickly. You would not have that option with the blockchain technology. The other issue is there's a famous cryptocurrency called Monero. I don't understand how ring encryption works, but it uses what they call a ring encryption to allow for discrete payments. So I could pay you. Okay. No one would be able to tell that I paid you. They might be able to tell that I paid someone, but they couldn't tell who I paid or that you received. They could tell you received the money, but they couldn't tell who you received the money from. Right now, Monero only processes something like $100 million a day, so it's relatively small. I think it's just catching on. So if someone wants to do some sort of large scale laundering of money, it's not scaled yet to the point where it could do that, but that is certainly a capability that can happen in the future, and the government would have a really hard time tracking that. And to my knowledge, there's not a mechanism right now to place controls on that. So those are some of the limitations of the blockchain. And I'll talk about one more. Okay, we'll talk about cyber attack. The most famous blockchain I already talked about a little bit is called Bitcoin. There are specialized computers called ASICs that operate the Bitcoin software. All of the ASICs in the world, if you combine them, they consume about the same amount of electricity every year as the nation of Sweden. It's absolutely an enormous amount of electricity and an enormous, incomprehensible amount of computational power applied to running this blockchain network. The most common type of cyber threat to a blockchain network, at least in a proof of work network like Bitcoin, is overwhelming the computers that currently run the software. It's called a 51% attack. So if I set up my own blockchain, I'm running a blockchain, and it's very poorly supported, you could go out and say rent a bunch of processing power from Amazon, and then you could use that to temporarily overwhelm my network and make whatever changes to the blockchain you wanted to make. Now, that would probably be impossible with blockchain because you couldn't possibly rent the copy. Even if you rented enough computers that consume the same amount of electricity as the nation of Sweden, you still couldn't overwhelm the blockchain network because they have specialized computers that have a hash rate that would far exceed what you could muster. So you would have to have some sort of manufacturing process. The risk here is that if the government decides to set up their own blockchain, and whether they have it be publicly supported by paying other people to do it, or if they support it themselves in their own data centers, if you get into a hash rate, I guess, war, where you're just both sides are applying massive amounts of computational power against one another, if your opponent overwhelms you, then you will lose control of your blockchain. But conversely, on the good side of that is on the slide, you can see the Muter Corporation's ATAC framework, which is a popular way of categorizing all the various flavors of cyber attack. There's entire categories of cyber attack that just don't apply to a blockchain that do apply to a traditional IT system. This isn't to say there aren't cyber attacks for a blockchain, but if you're using a blockchain, you're going to be well outside the bailiwick of most organizations that have set themselves up so that they can attack a traditionally structured IT system. Okay. And I imagine at some point in the future, the technology just isn't mature enough. Muter Corporation will come up with an ATAC framework for blockchain networks that will try to categorize all of the different types of cyber attack for a blockchain, but it's not mature and it is not well developed at this time. So as it remains right now, remember years ago when folks said, "Oh, well, Apple computers don't get viruses." It's just because Apple wasn't very popular. Over time, those things started to develop. Exactly. Will the same thing happen with blockchain? It doesn't seem that way. It seems unlikely just because of the way the proof of work and proof of stake mechanisms function. But that could happen in the future. Right now, there are far less options for cyber attack, and blockchain would be far more resilient to cyber attack than a traditionally structured IT system if it was going to be outside of the DOTA. So I think I'm right at about time, but those are two of the big drawbacks to blockchain technology, two possible applications for blockchain technology, and a quick down and dirty description of what it is. With that, sir, I'll turn it over.
No, that was mind-blowing. That was great. That was very exciting, actually. And outside of the two use cases, were there others that you looked that could have potential, but just decided not to focus on, or were those really the two key applications that you were able to discover?
When I first started, I made a very long list of all the potential applications, and then had to sift through them along with Dr. Jensen, and force ourselves to be more disciplined about the ones that we would focus in on. Okay. Just to make the app, because I think the idea is really, hey, there's two potential applications where this could work really well.
Okay.
All of the others work less well. So the argument isn't as strong if you're trying to nudge folks into saying committing R&D funds to further research and development.
Okay. Now, do you plan to continue this after a red? Because once you graduate SAW, this will not necessarily be your project. Is this something that you want to try and continue on after the fact?
So I'm going to the Marine Corps Warfighting Lab
Okay.
after this to. I don't know if it's going to apply to my future job.
Okay.
It's something I'm certainly going to keep tabs on, keep my thumb on the pulse of, and probably continue to nudge the institution.
Good.
Not in a formal capacity though.
Good. Okay. No, that's very exciting. We'll open it up then to questions from our virtual audience or audience here in the room.
Yes, good morning, sir. I have a bit of a two-pronged question regarding the orders distribution use case. Part one is, how is the blockchain idea any better or different from mesh network communications? And part two of it is, how does one protect against data poisoning, spoofing, other such things when the technology by necessity is impossible to correct mistakes on?
Yeah. So the in terms of the spoofing, that's the consensus algorithm. So if you have a consensus algorithm running, then that's how you protect from spoofing. Spoofing is a whole lot harder to do on a blockchain because, like I said, it requires an enormous amount of computational power. And then the other question was, how is it better than a mesh network? Only that if you have a blockchain and you develop a set of standardized messaging protocols, not unlike you have with, say, J series or K series messages, and you could store those on a blockchain, which can be accessible from to any member of a coalition, then that doesn't require the purchasing of specialized radios, having special waveforms, and there's no reason that a blockchain couldn't be integrated into a mesh network. Because when you're talking about a mesh network, you're talking about moving information from point A to point B. And a blockchain is not a network; it's an IT system. So when you're talking about an IT system or blockchain, I'm not solving the move information from point A to point B problem. I'm just trying to solve the problem of standardizing messaging so that it's interoperable for anybody within a coalition environment. But absolutely, if you have those standardized messages and they can be sent via some sort of integrated mesh network, I don't see any reason that it couldn't be, because then we're talking transport, not IT systems.
My my main other question here, sir, would be about data storage on board ship or data storage on board other forward deployed items, UAVs, aircraft, whatever. Considering the aforementioned and noted problem with large blockchains being just vast, and the necessity of the problem that causes in the electromagnetic spectrum if everyone's going to be constantly updating their blockchains because it's automated software, and which would cause problems for signature management, emissions control, and various other forms of electronic security. Over.
Yeah, I'm glad you brought that up. I didn't talk about that enough, and it's a good question. So the entirety of the blockchain doesn't have to be maintained on every node in the network. You could pick key flagships. You could pick any number of locations that you do or don't want to maintain the entire blockchain, and then those messages could be sent out to say whatever device you're going to use to prosecute a target, say an F-35. And that F-35 obviously doesn't have to carry the entire blockchain. And then the messages that are sent back and forth, a blockchain is like an IT system, and that if you have an IT system that is designed for something, it's usually designed to do one thing really well. So you may have an IT system for making sure everyone gets paid their salary on the 1st and the 15th. You can have an IT system for sending and receiving email. You can have an IT system for making sure cybersecurity updates are pushed out every Tuesday. A blockchain is the same way in that it would be specialized for whatever task you assigned it. And also, there's no reason that you couldn't have most of the computational power applied to a blockchain kept ashore, because keeping it on ship may not be the most efficient place to maintain that blockchain. So the blockchain could be customized so that you could have, say, full nodes and partial nodes. This is pretty common. This isn't anything like crazy or wild. I think Bitcoin has full nodes and partial nodes. I think Ethereum, which is another popular cryptocurrency, has full nodes and partial nodes, and those can be assigned to suit the purposes of the coalition. But yes, you are going to, if you do have a full node and you're trying to keep that on like a small, maintain that through a very small pipe, like you usually are assigned on ship, that's not going to work. You're going to have some sort of lighter form or a partial node at sea that could be updated, say when you come in line of sight with a flagship, or when you have lulls in the demands placed on your communication systems.
Okay, that was exciting.
Sure.
Made me a lot more intelligent just by sitting next to you and listening to this. I look forward to seeing how we can possibly exploit this for future Marine Corps use. All right, that's all we have for this iteration.
Thanks for having me, sir.
Education is what's important. Training, preparation for the expected. Education, preparation for the unexpected.